Hi everybody, Brett from Westcon here. In this video, I'm going to demonstrate how you could use an elastic load balancer to evenly distribute traffic across multiple EC2 instances in a VPC. The reason this is important is really for a couple of factors. First, we want to build infrastructure that is as secure as possible, and by deploying an elastic load balancer, that becomes the entry point into your environment, which limits the exposure to EC2 instances to the internet. And additionally, it allows us to build a highly available environment for our customers. So if there's a failure at the Amazon infrastructure level or something in our application, potentially, depending obviously on how we've deployed the solution for that customer, it should be able to survive that failure. So if you've been following along with the video series, you should have created a virtual private cloud already, and potentially one or more EC2 instances with EBS volumes. I've logged into our demo account here, and I've selected the EC2 service. So I'm in the dashboard. You can see I have a couple instances running already. So let's check out exactly what we've got here. So here is the EC2 instance details. You can see I've gone ahead and already created 2 web servers and added those to our VPC. And I did that just in the interest of shortening up the time here. And I'll explain briefly how I did this. I created, let's say, for lack of a better word, a builder EC2 instance. And I used that instance to install, in this case, Apache, patch up the operating system, and configure Apache to start on, or auto start when we boot up the instance. Once I did all those tasks, I created an Amazon machine image, or an AMI. And you can see it here. I've got web server version 2. I used that AMI as the source for these 2 instances that I've created that are actually housing our web servers. If I look at this and I pull up the details, it's not obvious here, but if you look at the VPC ID and the subnet ID over here on the right-hand column, I've deployed it in our demo VPC in a private subnet. And it's important to note that it's in a private subnet in the fact that this limits the inbound traffic to these EC2 instances. Since they're deployed in a private subnet, there is no direct access. So we're going to need a load balancer to allow customers to access the web application. And additionally, if we were doing this in a real deployment, you'd probably end up with a bastion host or a jump box that you could deploy in the public subnet in order to access these web servers for troubleshooting. So today what we're going to do is we're going to create an application load balancer associated with these 2 instances and see if we can get this to work. So the first thing I'm going to do is go down to security groups. I'm going to need a new security group for our elastic load balancer. So I'm going to click create security group, and I'm just going to call this ELB. Actually, let's make it a little better. Demo ELB security group. And again, just for simplicity, I'm going to make the description the same. If you're doing this for a customer, you'd obviously want something more descriptive. Make sure that you select the correct VPC, in this case, our demo VPC. And I'm going to go ahead and add just a single rule. I want to allow, in this case, HTTP traffic from anywhere. This is our public entry point, so anybody on the internet can access our load balancer through port 80. Again, if we were deploying this for a customer, making sure that security best practices are followed. We want to secure data in transit as well as at rest. So most likely what you would do is use HTTPS in a production environment to secure that data in transfer. But for the demonstration today, we're just going to use HTTP. So I'm going to go ahead and create this rule. And I'm going to just make the name the same here so it's easy to find. Now, this is our other security group that's important to note here. Right now, I'm just allowing SSH from my private IP address, but this is a web server, and we need to allow inbound traffic from, in this case, the load balancers. So I'm going to edit this. I'm going to add a rule, and I'm going to select HTTP. And in this case, I'm just going to start typing, oops, there we go. I'm going to just type SG, so security group, and I'm going to find the security group that we created, so demo ELB security group, and I'll save that. So now what's happening is we are allowing both SSH from our our public IP address as well as HTTP traffic from the load balancer. Now, for those of you that are sort of following along here in the private subnet, we don't actually have access via SSH. So we're just going to delete that rule. Again, if we were doing this in production, we would need some sort of way to access this web server, probably SSH from the Bastion host. But to keep this simple, we're just going to remove it. Now that we have our two security groups set up, we can go ahead and create our load balancer. Now, I've set up the security group already. That's just the way that I like to do it. You can, as part of the deployment of a load balancer, configure the security group while you're doing that deployment. I like to do it ahead of time, but it's up to you. So we're going to go ahead and select Create Load Balancer. There are two types of load balancer, an application load balancer and a classic load balancer. We're going to select the application load balancer. It gives us a little more flexibility, more feature-rich than the original classic load balancer. This is the new default. So we're going to leave the default and say Continue. And like we've seen before, we're going to have to give it some information. So I'm just going to call it Demo ALB. There are two types of load balancers that we can deploy, public or private. We're going to deploy an internet-facing or a public load balancer, so we'll leave that as default. The load balancers also support IPv6. We're going to leave this as the default of IPv4. And the listener in this case is the default HTTP listener. I mentioned already in production we would most likely use an HTTPS listener, but for this demo we're going to leave it with HTTP. The next thing we need to do is associate the load balancer with availability zones. So this is where you have to be a little careful, and this is something that's easy to mess up when you're first getting started. The first thing we need to do is just select the correct VPC. So in this case, we want demo VPC, and then it's going to show us the availability zones that exist within this VPC where we can associate the load balancer. So we're going to select 1B first, and although our instances are deployed in the private subnet, we still have to associate the load balancer with the public subnet. So make sure you select public subnets, and we're going to select both the public subnets. Okay, so now we've got a public subnet in AZ1B and a public subnet selected in an AZ1C. So now we've got that set up, we can continue on. If we wanted to add some additional tagging, which really we should for production workloads to be able to help understand cost allocation, you could do that by expanding out the tags here and add your custom tags. We're not going to do that as part of the demonstration today. So click Next, Configure Security Settings. Since we are not using HTTPS, we're going to get this warning. If we were using HTTPS, this would give us the opportunity to associate a certificate with the load balancer. So for today, we're just going to ignore this notice and continue on. The next thing we need to do is select the security group. So we went ahead earlier and created the demo security group for our load balancer. So let's make sure that we select that. And now we have to configure our routing. So we have to create what's called a target group. So we're just going to select or create what we'll just call a demo target group. We're going to leave the protocol as HTTP, leave the default port. Obviously, if you are deploying this for a customer, you may have to configure this based on the actual deployment that they're using. But for today, we're going to leave it as default. We're also going to leave our health check as the default. The one thing we're going to change here today, just to speed up the demo a little bit, is we're going to lower our healthy threshold to 3, and we're going to lower the interval on the health check to 10 seconds. So that means if everything goes as planned, we should have our load balancer come to life here quite quickly for us. Again, this would be dependent on what you're trying to accomplish for the customer, but today, like I mentioned, we're going to shorten these up for demo purposes. So once we've done that, we can click Register Targets, and we should see 2 instances. The load balancer knows this already because we have associated it with the availability zones and the subnets. So one thing to keep in mind here, I've seen other people do this, and I'm guilty of doing it myself, just on autopilot. You've done this a few times. Make sure that once you select your instances, you click Add to Registered first. So now you can see these two registered web servers at the top. Once you've done that, you can click Review, and here are all the details. So we'll click Create, and we'll click Close. And now you can see that our load balancer is coming to life. It's in provisioning mode, so it might take it a few minutes to come to life. But once that is done, we can check the health within about 30 seconds. And then if everything has worked as planned, we should see multiple EC2 instances in a healthy state associated with this load balancer. So let's see if it's done yet. Still provisioning, so let's just give it a minute and see how it goes. Okay, just a few minutes here waiting and a couple refreshes, and we can see that our load balancer is now active. You can see that in this state column 3 from the left. If we look down on the bottom half of the screen, we can see now that we've got tabs that are populated with information. The one that we're interested in here for today is the DNS name. So I'm just going to copy this. We're going to use it as a test in a minute. The one thing that I'll point out is resist the temptation to resolve the DNS name to an IP address. The load balancing service is a managed service, which means it's going to scale out and scale in based on actual demand on the solution that you've deployed on the Amazon platform. If you resolve this IP address and put it in as a DNS record or something like that, it may cause problems later on because the infrastructure that is actually delivering the ALB service may change. So whatever you're going to do for that customer deployment, just make sure you don't resolve IPs for the load balancer. Okay, so before testing this, let's have a look at a couple of the other pieces of interesting information here. So if we click on the Listeners tab, this is where we created our default listener, and you can see over close to the right-hand side a default action. So we're forwarding anything on port 80 to our target group that we created. So let's click that. That'll load up a new tab for us here. And if everything has gone well, what we should see here is under the Targets tab, there we go, our two instances, web server 1 and 2, and over on the far right-hand column is status. So in this case, they're both healthy, which means the health check that we configured, again, the default health check, listening on port 80, we shortened it up just to kind of help along the demo, means that the web server on these two EC2 instances is responding to those health checks. So that means if we open up a new tab here and put in our demo ELB, we're actually hitting that load balancer, and the load balancer is then forwarding on those requests to the the EC2 instances that are running our web servers behind the scenes. So if I refresh this, you can see we're still making connections. The load balancing algorithm is relatively simple. It uses the least number of connections. So we could actually test this out by going back to the Instances tab and just terminating one of these instances. So when that happens, now it might take it a minute. If we go back to our target groups, there we go. Immediately, we now have lost a host. But if we go back to our tab, as far as our end users are concerned, everything is fine. The load balancer realizes that instance is no longer part of its load balancing group, and it doesn't direct traffic to it. Okay? So thank you very much for watching. This demo has shown us how to create an application load balancer through the AWS Management Console and associate one or more EC2 instances to that load balancer. So thanks very much.